Mm. Oh, hi, Nomfundo. I'm sorry. I'm now back. I was just trying to record that side, like we were talking. Oh, you were telling me that you are ready, right?
Yes, sir.
Oh man, with everything.
Yes. Well, you haven't written paper one, so I'm not ready in paper one, but then paper two, I'm ready.
So you are ready with everything when it comes to paper too.
Yes.
Oh wow, wow. That makes me feel good. Hey, even with trigonometry, statistics, analytical geometry.
Yes.
Oh man, oh this makes me glad. Hey, oh I love hearing this. Then, without wasting some time, let me just quickly share my screen. You will let me know if you see something that side, ne?
Yes, sir.
All right, all right. Do you see anything?
Yes, sir.
Ah, okay then. Well, my files. These are my files. Grade 11 textbook is this one. Bum 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 bum. Then why? I'm still paging up to this page. So I've sent these two problems there in in the channel. Did you try to attempt them?
I didn't see them, sir.
Sorry?
I didn't see them.
Oh, did you even check?
Nah.
I knew it. You sounded like yes, you didn't check. But yeah, I did drop it. So guys, please maybe every after maybe 30 minutes after the lesson, every 30 minutes after the lesson, do maybe check in the channel if I posted something because I always post every 30 minutes after the lesson something that you can work on there.
Yes.
Yes, yes, please guys. So without wasting any time, let's quickly dive into the business for the day. So give is the zooming okay with you that side? Are you able to see everything?
Yes, sir.
All right, then thank you. Now in exercise 12 solving riders, AC, we are given AC as the diameter of the circle. Or using the RCPT, we can just notice something here. There's a diameter. What does that imply? This implies that now this is going to be 90 degrees. My paper is still paging, still loading. Okay, there we go. And then now, because there exists that diameter, now what I'm going to do is that angle B. Do you agree? If I say
Yes,
now
sir.
this angle is 90, do you agree?
Yes, sir.
Okay, we are saying angle B is equal to 90 degrees. Reason being,
Angles in a semicircle.
okay, I agree, 100% correct. And now we are saying angle B is equal to 90 degrees. And this is angle, this is 90 degrees. You are saying angle in a semicircle. Okay.
Yeah.
Now, sorry?
Nothing, sir.
Oh, okay. I thought you wanted to say something. Now, B is a point on the circle. OP bisects AB, meaning now that AP is equal to PB. Okay. Do you also agree or disagree if I say angle P2 is 90 degrees?
Uh, on which reason, sir?
Oh, I wanted to hear on your side. If you agree, I'm going to ask you a question why. Also, if you disagree, I'm going to ask you a question why.
Mm,
Is it still only you who are who is in this room? Let me just quickly check. These people are not attending. Where are they? Are they enjoying the weekend? I think it's only you, even now. But okay, let's continue with the business of the day. But yeah, we are here. Do you agree or disagree when I say angle P2 is 90 degrees?
I I I disagree, say,
Oh, why do you?
cause like there is no reason we can
Oh,
say that.
okay. Then now I say to you, it's guaranteed that angle P2 is 90 degrees.
Reason, sir?
Oh, theorem one. Do you have some theorem that we can quickly check there with you now? I mean, not theorem two. I mean theorem one. Yes, it's theorem one. Because
Yes.
theorem two. What is it saying?
Oh, theorem one. Oh yes, sir. Now I agree.
Yeah, theorem one. Therefore, now angle P2 is 90 degrees, right?
Yes.
Now, we are required to prove that OP here, OP is parallel to BC. How do you think we are going to prove that this line OP here is parallel to the line BC here?
We're just going to say oh, P2 is equal to angle P2 is equal to angle B
Oh,
corresponding.
oh yes. Now you can say therefore, after we said angle P2 is equal to 90 degrees. Then you state that theorem one. Okay, now we say therefore line OP is parallel to the line BC. Then that is the converse of corresponding angles. And then you state those angles that P2 is equal to angle B, then you are done. Does it now make
Yes.
sense, everything?
Yes, sir.
Oh, okay, thank you. Then let's now continue to the next one, which is this number 2 here. This one. How can I now score? I want to score. Okay, number 2. Number 2 is saying uh, PQB is just a tangent to the circle QRS at Q. Okay, this is nice. QS bisect BQR. QS is a line, bisect BQR. And then now we can see that angle Q2 is equal to angle Q1. They are both equal to those dots. Okay, now we are required to prove that the line QS is equal to RS. How do you think we can approach this question? Are you having some ideas?
Using the Tanco theorem.
Okay, how maybe?
Uh,
Time-code theorem. How? Which angle
uh,
is equal to which?
I think Q1 is equal to B.
You
I
are
can't
saying
see.
okay, let me do this. Okay. You are saying this angle is equal to
So I can't say this angle at the other end. I think it's Oh, it's R.
Yes.
Oh, yes.
So you are saying angle Q1 is equal to angle R, reason being tan chord theorem. I agree. Okay. This is good.
Yes, sir.
Okay. Yes.
Then we mark.
Pardon?
Then we say that if Q2 and R are equal, then QS is equal to RS.
Okay, I love this. But, okay. Now you can just say angle R here is equal to angle Q2. This
Hmm.
is Q2. They are both equal to Q1. Okay. Then if these are equal, you are saying now the line QS is equal to RS.
Yes.
I mean, this is an isosceles triangle because of those angles.
Hmm.
Isosceles triangle. Then you are done. This was simple, eh?
Yes.
Let me, let me quickly check who has joined. But I think it's only you. Where are my friends today? Oh, someone has joined there. Lavella. Hey, hi, Lavella. Is it Lavella or Lavella? I mean, I'm sorry if I pronounced this incorrectly. Hi, Lavella.
Hello, sir.
Hey, how's it, man?
Okay, sir.
Cheers. Here, man. Okay. Let me not judge you for being late, but you got here. We were busy with these questions here. Did you try to attempt them there in the channel? Because I've sent some there in the channel. These problems. Can Lavella hear me? Can you hear me?
I didn't do them, sir.
Oh, all right, man. So we now just did this question here, number one here. Let me just create this. We did number one here, and then let me erase this so that you can also participate in this, Lavella. Uh, erase this. You also must participate in this. Now, I'm saying to you, we are given that AC is the diameter of the circle, the center OB, the point to the circle, OP bisect AB, such that now we have concluded that AP is equal to PB. Okay, prove that OP is parallel to BC. Now, do you agree, Lavella, if when I say this angle here is 90 degrees?
Yes, sir.
Why?
English is nice. Mistake.
Oh, yes, angle in a semicircle. So we are saying angle B is equal to 90 degrees, not 96. Angle in a semicircle. Okay, that's a mark. Now, do you agree when I say this angle P2 is equal to 90 degrees?
Yes, sir.
Why?
Um, um, because they are corresponding.
Oh, no. Why are they corresponding? Why?
Uh,
Because I think in order for some angles to correspond, yes, they can correspond, but there is a reason behind that correspondence. Corresponding maybe because this is parallel to that, this is parallel to that. So now why are they corresponding? Why are you saying they are corresponding?
I don't know, sir. I don't know the reason.
Oh, cool. No, it's fine. No, it's cool, man. I don't judge you. But P2, do you have some theorem that you can look at now? Maybe with the book. Are you having some book with you there that you have some theorems that you can look at? Where is my friend now, Lavela? Can you hear me?
Yes, I can hear you, sir.
Okay, I was asking if you have some theorems that you wrote down, maybe on a paper or a textbook that you are having there with you now, currently.
Yes, I have a textbook, sir.
Okay, man, you can go to theorem 1 there and tell me maybe what it states. Theorem 1.
Theorem 1.
Yes.
It says the line drawn from the center of the circle is perpendicular to the chord.
Bisect the chord, right?
Yes.
Oh, meaning now this is the converse of that. The converse of that is that if the line drawn from the center of the circle bisects the chord, it means that where that line and the chord intersect, they intersect perpendicularly. Therefore, that's why I say angle P2 is 90 degrees. Does this part make sense to you?
Yes, it does.
Okay, thank you. So now for the reasoning will be that theorem 1. Now you can come to the conclusion that OP is parallel to BC. It's the converse, because we are proving the lines, converse of corresponding angles. Corresponding angles, then you state those angles, because now angle P2 is equal to angle P, then you are done. Does this make sense to you?
Yes, sir.
Okay, thank you. Then let me proceed to the next question. What did I do? Why did I just scroll like that? Bum, 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 bum. Where was I? Dun, 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 dun. Oh, almost. We are here. Okay. Okay, now we are on number 2. Let me just quickly check who has joined the lesson. Or still the 3 of us in the room. Oh, it's still a 3 of us. No, level. But okay, I believe they are still enjoying the weekend. So we have number 2 here, Lavella. And number 2 is saying, given that PQB is a tangent to this circle, QRS at Q. Then now QS bisects BQR. Bisects BQR such that now angle Q1 is equal to angle Q2. They are both equal to those dots. Excuse me. We are now required to prove that QS is equal to RS. What do you think we can do now to prove this? Are you having some idea?
Q1 is gonna be equal to R.
Oh, okay, 100% correct, my brother. Oh, what's happening, man? I thought I erased this. Hey. But yeah, I agree to that, 100% correct. Is let me zoom a bit. Okay. Yeah. Now we are saying, you are saying, in fact, not me. You are saying these angles are equal. Q1 angle is equal to R. It's an angle. What's the reason behind that?
The 10 chord theorem.
The turn chord theorem, 100% correct. Turn chord theorem. Okay, 100% correct. And then now what can we do to move on? And now what else can we do to proceed with the question?
I think Q2 is equal to R. Yeah, Q2 is equal to R.
Okay, Q2 is equal to R. Okay. Reason behind that?
Angles opposite equal side.
Which opposite side are you talking about? No, that's incorrect because now this is correct. Yes, R and not R2. My bad, just R. R is equal to Q1 and Q2 is equal to Q1. What you can say here, you can just say they are both equal to Q1. Does this make sense?
Yes, sir.
Okay. Now, if these angles are equal, now that's an isosceles triangle. If these angles are equal, that's an isosceles triangle. This implies that this side is equal to that. Therefore, you now can conclude by saying SQ or QS is equal to RS. Reason being isosceles triangle. Isosceles triangle or sides opposite equal angles. Then you'll be done by doing that. Does it make sense?
Yes, sir.
Oh, okay, guys. Thank you. Now we can just proceed to the next question. Number 3. This is going to be the nice question. This is good. We are given that ABC is a tangent to this circle. Oh, I would love if you guys can attempt this question. This one, I don't even want to give some hints. We are given that ABC is a tangent to this circle. BED is a circle. We are given that BE is parallel to DC. That's a powerful information. Now prove that D1 is equal to angle C. Angle D1 is equal to angle C. Any one of you guys who have got some idea of how we can approach this question? Hmm. Is there any diameter, guys, to this circle? Seems like my friends are no longer here. Are you guys still there with me? Oh, where are these guys? Are you guys still there? Yes. Yes. Yes, my friends are both still here. Can you all guys hear me? Oh, these people are quiet. No, Fundo just opened the mic.
Yes,
Let
sir.
me. Oh, okay. What about Lavella? Are you still there, boss? Oh, he's no longer here. Where is my friend now?
Mm-hmm.
Lavella, are you still there? Oh, my friend is quiet. Fundo, can you hear me? Can you proceed?
Yes, sir.
Oh, all right. So, here I used my favorite technique on riders, DRCPT Dr. Cape Town. So now my question to you, Nomfundo, is there any diameter to this circle?
They didn't give us any, sir.
Okay, then we can scratch that out. Is there any radius?
No.
No. Is there any cyclic quad? Is there any cyclic quad there, Nomfundo?
Mm,
Sorry?
no.
Okay.
No.
Oh, okay. Yes, I agree. Is there any parallel lines?
Yes.
Oh, yes. Then now there are those parallel lines B is parallel to DC or CD. Now with that, you can see that. Oh, do you agree if I say this angle? Not that bad. Do you agree if I say this angle is equal to that angle?
Yes.
Okay, okay, okay. I think that's all for now I can say. Now, oh, okay, that's all now I can say. But I can also say this angle and that angle are supplementary. Do you agree? Where is Nomfundo now? Are you still there?
Yes, sir.
Do you agree if I say angle E and angle D as a whole are supplementary?
Yes, sir.
Oh, yes. Now also this angle and that angle are supplementary because quintile angles, but I don't think we are going to need that. Okay, but let's do this. We are done with this one. R, wait, I remove it, but it's fine. T, is there any tangent to the circle?
Yes.
Oh, yes. Now what can we do using that information? Do you agree if I now say this angle is equal to that angle and this angle is equal to that angle? In fact, let me use different colors. This ones, let me maybe use green. Do you agree with these angles that I've just highlighted here? Where's my friend? Are you still there, show me? Are you guys still there?
Yes, sir.
So I'm now asking, do you agree with those angles that I just highlighted there or not? Still there, no one has joined the lesson. Oh, it's still only three of us. Yes. Yes. Mfundo, were you saying something?
No, sir.
Oh, okay. I thought you wanted to answer the question. Do you agree? So Lavella left us here. Lavella, are you there? Oh, this guy left us here. Okay, and to just save some time off to do something. So there's that tangent. Now I'm saying this angle is equal to that angle, tan chord theorem, and this angle is equal to that angle, tan chord theorem. We are required to prove that D1 is equal to this. Oh, D1 is equal to C. Where is D1? D1 is just this one here. We want to prove that this angle here, D1 is equal to angle C. Okay, now what we can do with this one, all those parallel lines, we can just say, let this angle be x. This one, B1, be x. Therefore, angle C will be x as well. That angle there. Why? Because of the corresponding angles, then you state your parallel lines, BE and CD. Now that angle B1 is equal to angle D here is equal to X as well, tan chord theorem. Therefore, now this angle C will be equal to D1 there. They are angles. They are both equal to X. Then you are done. Okay. Move to number 4. Number 4 here, we are given that the properties of a cyclic quad, opposite angles of a cyclic quad are equal, and that property of exterior angle of a cyclic quad is equal to interior opposite angle. Therefore, this angle will be equal to that angle. Okay. Now, what are we going to say? What we are going to say here, we can see that angle D2 is equal to angle A1. Therefore, and that angle A1 in this cyclic quadrilateral ABCD, we can see that this angle here is equal to that angle. Reason being exterior angle of a cyclic quad is equal to interior opposite angle. Okay, and then now what can we say? Are you saying something? Oh,
No, sir.
you're not talking to me. Now, that angle there, 8. What are we required? We're required to prove that DC, this line, is equal to DB, is equal to this one here. So now, what can we do? Well, this question is a little bit challenging. Okay, that's
Sir,
side. Hello, yes?
you highlighted the wrong line.
DC and D. Oh, my bad. Thank you for that. Okay, thank you for that. This angle is equal to that angle, we agree. But now DC should be equal to DB. Oh, this one. Thank you. And then now, this angle, let me use a different color. This angle is equal to that angle. So if, let me just use variables here, let A1 because A1 is equal to A2. They are both equal to X. Therefore, this is X here. This is X here. Now angle B2, there will be X, reason being angles in the same segment. Same segment. Okay, this is X. And then now, if this is X here, that will be X as well, because so now angle C there will be X. Everything there in C is X. Exterior angle is equal to interior opposite angle of a cyclic quad. Okay, now in this triangle, this is an isosceles because of those sides, of those angles I mean. These angles are equal, therefore these sides will be equal as well. Now, therefore, DC is equal to DB. Reason being those angles, sorry, my bad. Those sides are opposite equal angles. Sides opposite equal angles. Then you are done. Does it make sense, guys?
Yes, sir.
Okay, thank you. Let's move to the next question. Now we have this question saying that, given that in the sector A, B, C, D, E, A, B, C, D, E, B, C, and AD are parallel. Okay, a parallel chord. Okay, AB is produced to F. Now name two cyclic quadrilateral. Remember that now, if this is a cyclic quadrilateral is the quadrilateral that its four corners touch a circumference. So this would be my cyclic quads in this circle. Therefore, now to identify the cyclic quads in this circle, we are going to have the cyclic quad A, B, C, D, and the cyclic quad B, C, D, E.
E.
Do you guys agree?
Yes.
Okay, thank you. Okay, and then now the next question is requiring us to prove that B1 is equal to E. So what is B1? B1 and E must be equal. Oh, since BC is parallel to AD, we can say that this angle is equal to that angle, corresponding angles. Do you guys agree? B1 here. Corresponding angles. BC is parallel to AD. Do you guys agree to that?
Yes, sir.
Okay. Therefore, now, if or that angle, there's that bow tie shape here now, this one. Therefore, this angle will be equal to this angle, angles in the same segment. Therefore, angle A now is going to be equal to angle E. And then our angles in the same segment. And then now we can say B1 is equal to angle E because they are both equal to angle A. Then you are done for number one. Does number one make sense, guys? Oh, my friends are now quiet. Why are you guys quiet? Does it make sense?
Yes, sir.
Okay, thank you. Then let's proceed to the last one. Question of the night. Now, prove that D1 is equal to angle A. D1 is equal to angle A. Oh, how are we now going to prove this? This is equal to this. This is challenging. Okay, angle A is equal to angle E. We saw that. D1 and A. Okay, let me note the questions that we have. This is equal to that, and that is equal to that. Okay, what else? Now, D1 and A, how can we do that? Boom. Okay. This is the cyclic chord. Oh, this question is not bad. So now how can we do this question? This is what we can do. Do you agree, guys, if I say angle A there plus angle C? That gives me something like supplementary 180 degrees because they are opposite angles of a cyclic chord.
Yes, sir.
Okay. Therefore, if this angle is x, if angle A is x, if angle A is x, let angle A be x. Let A be x. This will be x plus C is equal to 180 degrees. Therefore, angle C is equal to 180 degrees minus x. We have angle C now as 180 minus x. Now we want angle D1. Angle D1 and angle C are co-interior angles, then they are going to be supplementary. Now we are going to say angle C plus angle D1 is equal to 180 degrees, reason being co-interior angles are supplementary. Do you guys agree to this? Do you guys agree to this statement? Oh, my friends are quiet. Let me just continue. I was saying C and D1, then what was C? C is 180 degrees minus X plus D. 1 is equal to 180 degrees. Then we want D1 there. D1 is equal to, we transpose 180 to that side, is going to cancel. When X is going to that side, is going to be this. Therefore, now we can see that our D1 here is X is equal to C. Where is A? Where is my A? My A is up. Oh, we let A there be X here. Here we said A is X. Therefore, now what we are going to do, we are going to say this is equal to A, and then they are both equal to X. Then you are done just like that. Does it make sense to everyone, guys?
Yes.
Okay, guys, thank you. I think let's end here for tonight. And I appreciate your presence, guys. Thank you for being with me. I will see you again next week. And enjoy the rest of your weekend.
Thank you, sir.
Thank you, man. Have a good night.